Welcome back! Today we're going to be starting our first project, the Doomsday Algorithm. In short, it is a weekday calculator. When a specific date is entered, it will tell you the day of the week that it happened on. The reason for this project is to teach you the importance of methods and how the lack of them can create totally messy and unreadable program. This project is of increasing difficulty, meaning a student with some basic knowledge should be able to create this, but also be challenged. First of all, I'd like to tell you about some prerequisites for this project. Without using these, this project will be much more difficult.
Mr. P.
First of all, this algorithm is very loop-based, including both while and for. You can use an example of this on the screen right now, as well as the output when the program is run. Both of these programs do the exact same thing, but one uses a while loop and the other a for loop. You will need these quite a lot. Secondly, you also need to be familiar with conditionals, like if or switch case statements. You can again see two examples, one of each conditional statement on the screen. If you are only familiar with if statements, I'd advise you to look into the switch case as well. They're a fundamental topic of programming, which can simplify the use of if statements by combining massive blocks of code into more manageable and readable code. Lastly, the knowledge of modulus, operators, and arrays will be very useful when completing the Doomsday Algorithm. The modulus operator, if you remember, returns the remainder of two numbers after division. A few examples you can see on the screen. By operators, I mean the simple math ones, like addition, subtraction, multiplication. This is when we are using a symbol to show what operation needs to be done by the computer. Arrays should also be used to store and access information efficiently, like printing the final statement, your day happened on a Wednesday. Our initialized weekday array looks kind of like this. Now that we have all of this out of the way, let's dive right in. First of all, let's familiarize ourselves with the actual algorithm. For this, we can thank a famous English mathematician. First, you need to memorize that Sunday is a 0, Monday is 1, 2 is a Tuesday, and so on until you get to Saturday, which would be 6. Then it's important to remember the 4 anchor dates. These are related to the centuries. The 1800s would be a Friday, the 1900s would be a Wednesday, the 2000s you want to remember Tuesday, and for the 2100s that's going to be a Sunday. This cycle repeats every 400 years, so 2200s, those would be Fridays again. Once you know these values, the algorithm itself follows these 6 main steps. Step 1. Divide the last 2 digits of the year by 12 and keep the whole integer. Step 2. What is the difference between the last 2 digits of the year number and the product of the multiples of 12 from calculation 1? Step 3. Divide the result from step 2 by 4 and keep the whole integer. Step 4. What is the century's anchor day? Step 5. Add up all the results. Step 6. Use modulus on the calculations from step 5 with 7. This will result in a number between 0 and 6, which corresponds to the doomsday of that year. After that, it's easy. You know your doomsday, and you can find your corresponding date. Every month has a different doomsday, like January 3rd, February 28th, or November 7th. I'll show you how this is applied using November 12th, 2003. Firstly, we will take the last 2 digits of the year, 0 and 3, and divide it by 12. Since 12 doesn't fit into 3 even once, the integer division would yield 0. Next, we find the difference between those last 2 digits of the year, 3, and multiply it by the result of our last calculation, 0. 0 times 3 is, of course, 0. Now we use integer division to find how many times 4 fits into our test calculation. 0 divided by 4 is once again 0. Using our anchor days on the right, which repeat every 4 years, we get Tuesday, which translates to a 2 in terms of digits. Our final step is adding all of those numbers together, which gets us a 5, and this will translate to Friday. We got to skip over a step because our final result is less than 7, so we didn't have to use Modulus. Our final step is calculating the actual day from November 7th, Tuesday, which is done by simply adding 5 more days to our Friday. So now you all know that November 12th, 2003 happened on a Wednesday. If you need some extra revision for every step, refer to the link in the bio. Right now I'll be showing you how to start your project, but if you'd like a challenge, skip to the timestamp provided right here. I advise every person here to try and do it on their own first, and then come back if you need some help. On the right side, you see a time lapse of me writing the start to the Doomsday Algorithm. Here is the main class where all of our methods are going to be located. We'll start by initializing a scanner to take in inputs from users like the year, the month, and the day. We will then initialize our 3 main variables, which we will be using right at the start. Here's a little hint for you. I decided to take my inputs in as a string to help me anticipate some runtime errors I'll mention later. I advise you to do the same. As we'll be working with modulus and division, the strings will have to be turned into integers. This is what we're going to be using the parseInt method for. I then create a method called Doomsday. This is going to perform the steps 1 through 6 algorithm that we explained earlier. Our next steps are to figure out how to find the anchor year for each century in order to get the method to work. I've started for you by creating the methods, but now it's up to you to fill them in. You can use arrays, modulus, or any other advanced programming technique you'd like to. Good luck. After you are done with the most basic algorithm, there are some extra challenges that you could try to find an answer for. Some of these include errors, like if a person adds a year greater than 9,999, or writes a year that is not in the Gregorian calendar, something before 1538, or maybe if the user tries to add a string instead of an integer for the year, month, or day. You should also have precautions in place so that the user doesn't input a number for a month or a date that doesn't exist. Like, for example, if they try to put in a 13th month, or like a 32 for the date. Leap years also have different doomsdays. You should try and come up with a function, something like isLeapYear, that you can reuse. Finally, it's also very nice to have the final output say something like an actual day instead of a number. So it would translate 0 to the day Sunday. We'll be back in a few weeks' time with an answer video, and I'll go through everything with you. If you get your program done, be sure to send it to me by email. You can check the email in the description below. I look forward to seeing your answers. Bye!
Mr. P.
I'm a diva, right?